All right, hi everybody. Oh, actually, let me update my stream explanation. Um, hmm, Actually, I can't figure out what I want to say. What I wanted to say. Okay, so unit circle. Um, I said it wasn't scary, and I actually do believe this. Um, what even is a unit circle? Let's start with that. Right. So we got the circle. It's at the center of the x and y axes. So plus x this way, plus y this way. Um, so this is so if I'm anywhere in here, then it's gonna be a plus x and a plus y. So you can think of all this as always both axes are always going to be positive, both axes are going to be negative, and these two are mixed. Okay, so why is that useful? Well, what I'm going to talk about today is I have a game that I'm working on where I wanted grid-based movement. So basically, there's a bunch of tiles on a grid, and the movement system allows you to move from one to the next to the next. Which usually be pretty easy. You just say, okay, I'm at grid XY, and I want to move to grid X plus 1 Y, or X comma Y plus 1. Right, very easy. You just snap to it, or if you want to do diagonal movement, or if you want to subtract or whatever, like that's all straightforward. And I'm going to be using XY in this example because that's what the Cartesian grid you probably are used to in math school, in the high school math used. Um, in your engine, it's actually probably going to be XZ because Y in basically every game engine is the up axis. So basically, it's always going to be X X Z Y. But we don't even use Z in 2 dimensions, so XY it is, right? So what makes the unit circle useful is, so this is fine for top down, right? So if I've got a character here, right, and they're in a grid, and I want to move around, just adding or subtracting from X and Y to move them around is fine. But if I've got a 3D camera, right, if I've got a camera, then this doesn't work. Well, specifically if my head is a camera. This doesn't work, and the reason it doesn't work is that if you've played any first-person shooter on console, on PC, whatever, your movement. So, let's say I'm standing here, right? And I am looking that way. My movement is based on the direction I'm looking. So if I press the same W key, or left stick forward or whatever, then it's going to take that and it's going to multiply it by my camera angle to equal actually like the actual movement angle. So if I'm looking that way instead of this way, right? Then even if I do the exact same thing with my keyboard or my control stick, I'm going to move a different direction. Um, Not doing this is called tank controls. Why is it called tank controls? Real good question. We got this tank, right? It's got a gun, and the gun can move, and the tank can move, and they don't move together necessarily. So how does the unit circle help with this? Well, in my basic 3D grid movement, here are the assumptions, right? So my character can only move in discrete jumps, right? So I can't. So I'm only going to ever move 1 unit at a time. In my case, that unit is 2 meters because that's what happens to work for my game. Yours will be different if you're making your own game, right? It's only ever going to be 1 unit at a time, and I'm only allowing the player to move in 90-degree increments. So a lot of math with angles is done in radians and not degrees. So a 1 radian is well, let me put it this way, right? 90 degrees equals pi over 4 radians. So if we think of the unit circle here, and I'm going 90 degrees this way, or, minus 90 this way, just, pi over 4 radians, or minus pi over 4 radians. Same idea, right? So that's all you need to understand about the unit circle. Now, what I'm doing in my game, I'm actually not even worrying about angles, because, and this is actually super important, where we're going, we don't need angles. So basically, when you have the unit circle is drawn counterclockwise in this direction. So we start from 1, 0, and we move this way, and it's always that way, so, right? So any arbitrary line that starts from this origin and goes any distance, we can just say, okay, starting from this point, how much angle is this? And we've drawn Pac-Man. So let's take an example. Let's see, Desmos, I guess. Yeah, I've been trying to make this video for a long time. Math tools, graphic calculator, here we go. So this is gonna be a little bit rough because I'm like, I just want to get it out there. I just want to make it happen. I promise a polished video at some point in the future. But so our circle is x squared. No, what? What did I do? Okay, x. No. Okay. I'm using a dumb keyboard right now. Like I said, next the actual edited video will be polished. This video currently is not, as anyone watching right now can tell. I think I'll just also make an edited VOD because if I can avoid people seeing this awful dead air, I will. Anyway, as soon as I get this new keyboard plugged in, oh gosh. Is this it? Okay, yep, this new keyboard is plugged in. Great, now I can actually type things. So, x squared. Great, plus y squared equals 1. Right, so that's our unit circle. We can zoom in here, make it a little bit easier to see. And so if we, for example, write this angle right here. Let's see, 0.867, right, so, well, we can just take an approximation, so 0.867, comma, minus 0.4. Oh, did I miss? Is there a way to... Okay, good enough. Right, so we can see here. Oh, and I need to actually 0, 0, 0, 0. Do I make this a line? Okay, whatever. So imagine there's a line here. I wish I knew how to make the line happen. Imagine there's a line here, right? So we can start from here. We can go whoop, 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 around all the way to here, and that's our angle. So we don't actually need two lines to make an angle. We only need one because the other one is implied, right? Let's just go back to my art software. This might just be easier to use than Desmos, right? So you got your XY coordinate plane, you got your unit circle. You start here, you go this way. And then if you're going backwards, it's negative, you go this way. Make sure OBS is pulled up. Yep. You go this way. And that's basically how it works. Now, the reason this is useful to me right now is all of the places where it hits a coordinate, right? These are all really easy to solve. They're all really easy to solve. And the reason why is pretty simple. So, the equation for the unit circle, x squared plus y squared equals 1. And again, well, not again, I haven't said this yet. So you can put whatever here. You can put pi. You can put 1 over, 10 million. You can put 35. It doesn't matter, right? This is the formula for all circles that will ever exist, at least as far as the sort of a Cartesian grid you've learned in math class is concerned. I'm sure there's other coordinate systems that define it differently, but 1 is the easiest to work with. So if we understand that, so if x is 0, then there's only 2 possible answers for y, 1 and -1. Right, because when we square -1, that's 1, and if we square 1, that's 1, right? So let's draw our unit circle. All right, so here's our, and then you get, the reverse is true. If y equals 0, then x can only ever be -1 or 1. So starting with 1, 0, and then here's 0, 1, and then -1, 0, and 0, -1, and that's literally all of the unit circle we need. We can ignore everything that's not touching an axis here, at least as far as my game is concerned, because I only let the player move 90 degrees or pi over 4 radians. I don't you can't move 45 degrees or 60 degrees or 120 degrees. You can only move in increments of 90, and so all I have to do is move from here to here or here to here. And so what I've done is I've just taken these 4 points, I've put them in a little data structure. And I need commas between these. And 0, -1. Right, so here's my array. And basically, when I rotate my character, that means, so if I rotate my character and don't rotate the underlying grid, what happens is, let's say I've got my character facing this way, right? I move them 90 degrees, now they're facing this way, or yeah, 90 plus 90, or I move them 90 degrees, now they're facing this way, right? So the issue here is that this rotation, right, W equals up. So if I press the W key, I go this way. In this rotation, it still thinks W is up, but I'm facing that way, so I'm going to go like 90 degrees different than what I actually intended. So if you're facing this way, right, your camera's facing this way, W should be this way, and back should be S, right, this way, and so forth. And so what we actually need to do is this, and this is also the set of instructions. Let me actually pull up the code. I hope I'm explaining this well. I mean, I think everyone with their head screwed on straight is a little let's just say disappointed with the election results that came out today. So I'm a little unfocused, but yeah, so let's see. Yeah, so here's my array. I'm using 2 instead of 1 because my game just happens to work with that better, but so if I run my game, right? Right. If I run my game, it doesn't work, and I don't know why. Ah, that would do it. I put my player such that they can't actually move. Right, okay, so I'm in a hallway, so if I move left, nothing happens. If I move right, nothing happens. If I move back, well, we can see here, this enemy is here. It blocks my path. Right, great. Now I can move, right? And if I rotate, then... But, so if I'm always... So I'm pressing my forward button. I'm going forward, right? And forward relative to where I'm looking. And if I rotate here, left, I'm pressing my forward button is nothing is happening because there's a wall there, right? Now if I rotate back, I can go forward and back. And now, but if I press the side button, nothing happens because right, 1 unit wide hallway. But now if I rotate, I can move side to side because of how this rotation function works. And so that's what you can get with a very, very basic understanding of the unit circle. So basically what you do is you say, okay, if I want to go forward, I use this one. If I want to go, I forget exactly how I set it up. I kind of just brute forced it, I'll be honest. But yeah, we can see here. So forward is right. So forward is taking the x component of this, which is 0, and the y component of this, which is -2, right? So the way my camera setup is working, and this, obviously if you rotate the player, then this rotation is going to break, but the way my player is facing, so here's my transform, right? So I'm facing towards -z. Y doesn't really matter here. -z and -z, and then I guess, well, I'm not facing, actually, I'm facing perpendicular to the x direction. So which position, it doesn't really matter. But if I rotate 90 degrees on the y, right? Now you can see that in this editor, the positions have sort of flipped. Right, this bit, the camera has moved, but the arrows have not moved. And in my game, I need the arrows to move because then your movement stays relative to your position, and that's what I use this friendly unit circle here for. And what I'm doing basically is, if I want to move, I need a new slide. If I want to move forward, that's always going to be this where did I put it? Okay, so forward is always 3 0 3 1. And if that's confusing, there's 4 things in the array, so but computers count from 0, so 0 1 2 3. So this this 0 minus 2. This would be 0 minus 1 if I was sticking specifically to the unit circle, but it makes sense. It turns out that it's easier to do it this way than to multiply it later. So, but anyway, you got the forward, like forward is just these two units. So, you know, you go to the third thing in here, and you take the 0th option. So that right, and then you take the third column and you take the first option. So you know, 1 0 1. It's a little confusing if you're not used to it, but it makes a lot of different kinds of math easier. So that's forward, right? But what's actually in here can change, because if I go down here to rotation, what I'm doing is, okay, well this card is not, if you're not used to reading code, this code is a little hard to read. But what I'm basically doing is taking the fourth, gosh, how do I explain this? So rotation, I'm taking the first thing here, right? So I'm taking this, and I'm inserting it at the end. So what this looks like is, right, we have A, okay, we have A, B, C, and D, and I want to move D to the start, right? So what I'm doing is I'm taking a copy of D, putting it at the start, then we got A, B, C, D, which is not what we want, so we just get rid of this D, and now we've got D, A, B, C, which is what we do want, yay. And now that sort forward from earlier, right? It's still going that 3 0 3 1 to decide where, like, how much it's changing the position of the player. So the player is in a 2D grid, right? They can move here, but because they can rotate, I need to be able to change the position they're going to end up at relative to the rotation. So what we're going to do is we're going to take whatever the program thinks forward is, because we can, what forward is can change. It can rotate in this way. And so if I rotate so if I rotate right, that is going this way. Wait, sorry, no, right's the other way. No, never mind. As I said, this a nicer version of this will come out later with editing. Nice. Okay, so yeah, if I rotate left, that's this way. If I rotate right, that's this way, and that's plus 90 or 2 pi, and that's minus 90 degrees or 2 pi, or sorry, pi over 4. I keep goofing this. All right, so that's right. So we can get A, B, C, D. We can get D, A, B, C. We can get C, D, A, B, and so forth. But it's always going to be in this order. It's just like where the start and the finish is going to be different because I rotate them. Right. So if I do 4 rotations, then, you know, D's at the start, and then C is at the start, and then B is at the start, and then A is at the start. And if A is at the start, then we know that all of these have been moved around, and so it loops back around to A, B, C, D. And we can see that in game as well. If I run this, right, I'm facing, let's see, so I'm facing this way. Right behind me is the enemy, so if I press left, 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 left 4 times, same view. If I press right, 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 same view. Yeah, so that's what that is. And so this is a very, very basic example of what you can do with our friendly unit circle. But you might be thinking, isn't it kind of limiting to only move 90 degrees at a time? Yes, it is. So what do I do if I want to move, say, this much? Well, unfortunately, this is where the right triangles come in. And I don't actually understand this well enough to explain it. Which is kind of unfortunate because I'm the one doing the explaining here. So the short answer is, as to what you do is you start thinking about, right? So I said earlier that you only need, because we can assume this is the lower, so here's an angle, right? We can assume this line, this what do you call it, y equals 0. This y equals 0 line is the lower bound for the angle. And so if I have something equivalent to that, well, what y equals 0 for all x is greater than 0. So that's this way. Right, so we can assume that it's always starting on this line and going either positive or negative this way. Right, and so what you do is you do a more complicated version of what I just explained, where you take the players, the input angle, right? You take the input angle and you transform it by the rotation, the facing angle, to get the actual final. So let's say the input angle is here, the facing angle is here. You do vector math and you get the final actual angle here. But this is sort of where I run out of steam in terms of explaining all of this. Oh gosh, how long have I been streaming? 30 minutes. Ugh, that's not a super long stream. Anyway, I wanted to get this out of my system. We'll come back for part 2, and we'll also come back for part 1 where I edit it. Or maybe I'll just reshoot the whole thing. But yeah, that's a very basic use of the unit circle. I am actually using it right here. You can see how the code works. I should probably publish this on GitHub or whatever. I will do that. I'm not going to do that immediately, but I will do that such that when an edited version of this video comes out, you'll be able to read this code for yourself. I might also make it simpler and just like multiply this. Multiply to be less confusing, maybe? Yeah. Oh, actually, I wanted a visual example. Okay, let's do that. Let's do the visual example. So here we are in our friendly neighborhood Blender application. And we've got this cube, right? We're going to name the cube Joe. Come on. Joe Bert, right? And Joe Bert wants to go on an adventure. And so if we take, we go G, right? I can grab it, I can move it around. But if we rotate, so this program deals with absolute angles basically, right? So if I rotate Joe Bert and then I rotate Joe Bert again, and I rotate Joe Bert again, right? You can see that it's taking the last position. I'm explaining this poorly. Okay. Let's ignore rotations on the X and Y. We're only rotating on the Z. So here's our friend Joe Bert. Joe Bert wants to go on adventures. And if we G X right here, you can see we can slide him along the X. G Y, we can slide him along the Y. Great. But if Joe Bert wants to rotate R Y 90, R Y, nope, rotate. on the Y. Or along the Z, right, because it's the up here. Right. Now, in Blender, this just works, right? I can still move you the same way I would. But in our game engine, now that I've rotated you, you know what? I need to start this over. So here's Jobert. We need to Shift A, mesh plane, or maybe it's no. Shift A, mesh cube, and we'll just scale that to like 0.25. Great. Maybe 0.5. Oh, okay. There we go. Let's just Shift D. Right, so here are our WASD controls. So Jobert, you're going to go back to 0, 0. And then I'm going to... Actually, let's take this, move it here. So GX, there we go. Okay, right, so we got Jobert. Jobert wants to go on adventures. Jobert can move in 4 directions because we've decided that other directions are too complicated. So for a little bit, right. Oh. Right, so in Blender, I can just rotate these things arbitrarily and it's fine. But in the game engine, because there's the camera attached here, we're looking, say, this way, right? And so, I mean, you're a person, you've walked or, used a wheelchair or whatever in real life, and you generally want to be, like, wherever you're looking is where you want to be going relative, right? So if you walk forward, it's not relative to anything but yourself, right? If I'm facing this way and I walk forward, I walk toward where my nose is pointing, right? I mean, obviously you can look this way and walk this way anyway, but the way that 3D the way that 3D video games usually work is that there's no real definition between your nose and your feet, like they're all facing the same direction. And so what I need to do here is what I need to do here is something completely different. So Shift A, mesh text. Here we go. Oh, right, I need to tab into edit mode. W, right. Okay, tab into object mode. Right, okay, so let's actually get rid of this. There we go. So we got W, and then we shift D 3 times. Great. Now, tab in edit mode. That is a D. Great. Tab in edit mode. That is an S. Oh, come on. No. Have you selected tab in edit mode? That's an S. Great. And tab in object mode. Move this over a little bit. Tab in edit mode. Tab into edit mode, and here is an A, right? So we got the standard WAS layout. And so if I rotate all of these together, then Jobert can move forward, from the nose out, right? The nose is forward, W, if you're used to keyboard controls. And if I rotate this way, like just, off axis, or if I rotate like in any random angle, doesn't really work with 3D with XYZ rotations. It only works with XY rotations. Generally, the way it works is rotation. So in a 3D game, you've got two kinds of movement. You've got ground movement, and you've got, or how do I say this? So your ground moves here, right? You can move in these four directions, and then your camera can move in sort of left, right, or up, down. And as you can see, there is some overlap here. So basically, what you have happen is, if I have my character, if I move my mouse or my joystick down, then the character doesn't move at all, but the field of view does move. And so what you can see and what you can't see changes. And then if I move my mouse left, right, again, the field of view, like what you can see on your screen, moves. But also generally you move the character model. So in this case, let's say I was seeing my character model in third person, go from looking like this to looking like that. And but here, right, I'm going from looking like this to looking like this, right? So it's actually rotating the character rather than just moving ahead. And really, graphically looking up and down is like, this is mostly a graphical effect, so the hitbox is going to be the same and that sort of thing, right? Like if I have no matter what direction you're looking, doesn't really matter, because in a video game, at least on the this is confusing because Blender uses one set of axes, my game engine uses another. But looking left and right, if I've got a gun and I'm trying to shoot you, I can shoot you no matter what left-right direction you're looking at. And also I can shoot you no matter what up-down direction you're looking at. You have to move out of the way with your movement controls. But I will see, from over here, I'll see more of a change if you rotate around rather than looking up, down. And so right now, if I rotate this way, this gets a little bit confusing. Very few games let you rotate like this. Some flight simulators do. When they do, it's called 6 degrees of freedom. Pretty simple why. If you've got a cube, you can move forward. All right, let's actually finish drawing the cube. You can go forward, back, left, right, up, down, right? And then you can also do all the rotations. All right, so that's a total of 6. So, right, you can move plus X or minus X, and you can rotate along the X in either direction. So that's 6 degrees. But those games are relatively rare. Generally, what you're doing is you have one set of movement controls for basically the 2D portion of movement, right? So if you imagine a top-down grid, right, and I'm here, I can move here, and then in most games you can also move and sort of these in between angles. And then your camera sort of changes where you're facing, but moving your camera won't move your character. But in this case, because you've got 6 degrees of freedom, right? Let's say you're a fighter jet. Right? So here's your camera. If I rotate my camera, suddenly my fighter jet is sideways, because right? It's a much bigger rotation. Yeah, and then so the way that we carry these directions with us, the WASD, even again keyboard controls, the way that we do that in code is with the unit circle. We transform it along the unit circle, and I'm using fixed points, right? So my game currently only supports, and I mean this game, this is how I plan to ship it. I don't plan to say, okay, well, right now we can only do these 4 angles, but later we'll add this angle. No, I only ever want to plan to support these 4 angles. But this is the basis of how all 3D movement works, right? And it's also worth noting that there's like there's 3 planes you can move along in, right? So if you're used to 2D coordinate system, right, you got X, you got Y, right? This is the XY plane. Very easy to remember. It's a plane because it's flat. If you're used to, planes that go in the sky, same word, different meaning, right? And then we've just got 2 more planes, predictably called the, let's see, so, and again, the coordinate system is kind of a mess because different programs use different definitions of up. Anyway, so we got the XY plane here. We've got the Y Z plane. We've got the Z, and we got the X Z plane. I think I'm labeling these wrong, but anyway, that's the basic idea. So you've got these 3 planes, and most games, so they use the XZ plane is ground. Right, so you can go plus X minus X plus Z minus Z in sort of any combination. And then if you jump, it's usually, gosh, is jump minus Y or plus Y? I think it's usually minus Y. I can obviously check in the editor. So if I go, oh no, jump is plus Y, okay. Yeah, so jump is plus Y. So is it plus Y in 2D as well? I don't want to have to check. So that's usually the setup, and pretty much any game engine is going to be this is the movement controls. And you can see pretty clearly, I hope, how this sort of 2D Cartesian grid translates to the 3D, like you've got these 3 planes to work with, and you can rotate or move along any of them or any combination of them to make any sort of 3D movement. Right, we basically just take the XY, we add another one, let's call this one Z, or in the case of games, we say, okay, XZ is ground, and this new sexy one is up. And so if you're used to 2D transformations, which are actually not that bad, it's not as hard as you'd think to move up to 3D. And so if you're thinking, okay, well, you got the unit circle, you just told me about the unit circle, and we're applying this to the XZ plane, right? So I can rotate along the XZ, and I can move along the XZ. But what about that game you mentioned earlier with the planes, where if I rotate my camera, I rotate my whole plane? Well, good news, unit sphere. It's exactly the same as the unit circle, but it has 3 axes instead of 2. That's not a 2, that's an S. And if you want to calculate, right, remember we had, if we like any angle can be calculated by assuming this line is the other half of the sort of angle, right? So I can take any point along here. That's our angle. I don't need to define the other point. It's already defined. Well, the good news is this works in 3D as well. And I wish I could tell you more, but I'm still teaching myself exactly how this works. I believe how it works, don't quote me on this, is instead of using a line, you use a plane. So we just assume this plane is the basis, and then we have the sort of the 3D angle, which is like, it's kind of an open Pac-Man face in 3D. Don't quote me on this. This might be wrong, but yeah. And it turns out that the unit circle of sphere is very useful because those angles are only useful if they're scaled. So it's very, very easy to do math when both points are in the same circle, right? But if my point's way out here, and I would say, okay, well, what's this angle? Well, so first step, put it on circle. And how do you do that? With a square root. I mentioned triangles earlier. They're coming back. So, right, you probably learned this in middle or high school. A squared plus b squared equals c squared. So if we have, for example, a equals 3, b equals 4, right? That's 9 plus 16 equals 25. Square root of 25 equals 5, right? So we can, and then there's also stuff you can do with trigonometry. So if I know, 2 side lengths and 1 angle, I can figure that out, right? We're sort of just going to sidestep that for now. So if I want to scale an angle down, right, so here's my angle, and here's where I want it to be. It's useful to know that any right angle with the same ratio of side lengths is going to be basically the same object, just like times 2 or times a half or whatever in scale. And obviously you can rotate it as well, but we're gonna just assume it's always not rotated, right? And so if I have a 3, 4, 5 triangle, and you have a 6, 8, 10 triangle, or a 12, what? So wait, 3, 12, 16, 3 times 4 times 4 times 4, 12, 16, 20 triangle or whatever. They're going to be exactly the same. They're going to work exactly the same way. And taking the square root lets us scale it correctly so we can do our math on it. Wait, actually, I just realized I don't actually understand myself why that works. Well, that sucks, because I should know that. Because I know that square root, maybe it's a 3D thing? Because you can... Triangle similarity. Yeah, so one of the reasons I didn't want to make this, and I've been sort of putting it off, is that, here's all the knowledge I need to explain it. Here's what I have. I'm sort of working on expanding it, but slow going. Learning math is hard. Teaching math is hard, and we do a particularly bad job of it, and at least in the schools that I've been to. So I'm sort of having to figure it out myself. I know that it's very, very important to be able to do a fast square root for 3D things. So, right, Pythagorean theorem works in 2D. It also works in 3D. So we got this very simple 3D triangle, right? We got the lengths our ABC and our hypotenuse D. So we can do the square root of a squared plus b squared plus c squared equals square root of d squared. And we can find the hypotenuse that way. But what is, okay, so wait. Normalizing, wait, how do normalizing vectors work? Vector. 9 steps of pictures. Okay, we got a vector, you got a unit vector. Okay, great. V over. Okay. So why do we need to? Okay, so So let's say we have our unit circle here, right? Yeah, that's a terrible circle. Here we go. We got our unit circle here. Pretend this is to scale. And we got our point way out here. And we want to put it back on this unit circle. How do we do this? Very simple. Step 1, find this length. Step 2, divide that length by itself. So if this length is 10, 10 over 10 equals 1. So it'll be, because the unit circle is defined as x squared plus y squared equals 1, right? So that means that it contains the set of all line segments that have units that have length 1 and are that originate at the that start at the origin. So obviously, if I have a line segment out here, I have to drag it over here to make it work. And if I have a line segment that's way out here, I have to normalize it. That is, make it 1, radius of 1 to work. But you can take any line. Did not go to high school yet. Oh, well, have you learned this stuff yet? I completely forgot to explain why I'm calling this High School Math for Game Programmers. Give me a sec on that. I need to go find, and, okay, I can't find it quickly. So I'm going to be butchering this quote slightly. But basically, there's this game Wolfenstein 3D. Yeah, there's this game Wolfenstein 3D. And it was very advanced for its time. It's kind of a joke now in terms of what it can do, but it was very advanced for its time. And one of the main coders, when asked about this game, basically said, I'm not a wizard, right? Not a wizard. I just used, I just understand high school math well enough to solve real problems. And that's a John Carmack quote that I'm doing slightly wrong. Oh, yeah, that PDF. Oh, yeah, no, you totally have it. Yeah, let me, I don't like to have Discord open while I'm streaming. But yeah, just look through high school math in that quote, in that PDF. The quote should pop right up. I'm butchering it slightly. But yeah, that's the quote. And so yeah, high school math involves a lot of trig, involves a lot of unit circle stuff, and these are obviously very closely related. And it turns out, with a good understanding of just these two things, you can actually make a pretty convincing 3D. Yeah, Carmack is. He lives a little bit of a complicated legacy because politically he's gone off the deep end a little bit in recent years. So I don't want to say too many nice things about him. I'm not going to get into it. But as a coder, he's been sort of at the cut at the what do you call it? The leading edge of basically all 3D stuff for his entire career. So he made 3D engines for Wolfenstein and Doom and I believe Quake. And then these all eventually got open sourced. And we're basically still using this code to some extent, mostly Quake, right? Because Quake goes into the source engine. And then if you've ever played, for example, Apex Legends or Titanfall 2, those are both heavily modified versions of Quake, basically. So, like, that's super important. And right now he's working on VR stuff, which turns out requires a lot of 3D math because the thing exists in 3D space. So those are all great contributions. I don't think I'd personally get along with him, but that's a side note. Yeah, so I've basically run out of stuff that I actually understand. So I guess I'll just review it. Why not? So unit circle, right? We can move this way, we can move this way, and it's defined as x squared plus x squared plus y squared equals 1. So this every point along this is going to have a length of 1 because that's the radius of the circle. That's how circles work. And because of this formula, we can tell that anytime either of these is 0, the other one is going to be either -1 or 1, and those actually conveniently correspond to these 4 points in the circle that are 90 degrees away from each other. I'm making a 90-degree game where you can only move those directions, so I only need, right, we can ignore, well, so there's infinitely many points on the unit circle, right? So we can just basically ignore the entire circle. We can just be like, yeah, don't care, I only need these 4 points. And obviously this leaves a very limited movement, but there's plenty of games, old and new, that like this. What was it called? Inscription is one, right? Inscription, you have this weird, it feels sort of intentionally weird where you can move forward, back, left, right, and rotate, and that's it. And only in 90-degree increments. It uses, I mean, I don't know, I haven't read the code, I don't think it's even open source, but it uses something very similar to what I'm using here, which is basically I'm just taking these 4 points, I'm putting them in an array, and we're just going to name these A, B, C, D, so I don't have to type it all out. I don't have to write it all out all the time. So we've got A, B, C, D, which is these 4 points the unit circle touches the coordinates. And because I've got a camera attached to my player, I need the movement to be relative to the player, right? I can't just say, you know, if I press the W key, it always is going to go, you know, plus X or whatever. It's got to be related to the camera. And so basically what I do, I have A, B, C, D in a list. And if the player moves, how did it go? I need to read my code again. Yeah, if the player rotates, if the player rotates left, then we becomes B, C, D, A, right? And so all my code does is so to move forward, I just take A and I move my character sort of A, right? And because, right, if I'm at A, right, here's 0, 1, so from here's where I started, here's where I'm going, I'm moving plus this direction. But if I rotate the player, I am also rotating this grid. Come on, our program, work with me. I'm also rotating this. I'm also rotating this grid. Right? Right. And we're good. Right. So A is defined as forward. Right. It's always going to be forward. A is defined as forward, but I need to change what forward is. So that's how that all works. Oh gosh, come on. Yeah. So yeah, and then I need to teach myself a bunch of trig to make this more useful for everybody, unfortunately. Okay. I think that really is everything. Oh yeah, and basically that if you want to move in between, right? If you don't want to be restricted here, you basically need to do a couple different mathematical operations. First, you need to take whatever your line it is and make it of length 1. And the way you do that is you find out how long it is, and then you divide it by that length. So any length divided by itself is going to be 1. Great, you've got a unit vector, and now this makes calculations very easy. So instead of having this sort of brute force method, I just say, okay, here's where I want to go. Here's where I'm facing. Let's combine these two vectors into a final vector that's something like that. And a vector method is actually not that complicated in 2 dimensions as far as I know. I just am not familiar enough with it to sort of do it correctly. So yeah, and then yeah, this also works in 3D. So that's how that all works. Okay. I think I'm gonna have to call that the stream because I'm sort of out of content. This is also how school works, I guess, where just, you know, I mean, I've had classes that were longer than an hour. I haven't had good classes that are longer that other than one, but he broke it up into a bunch of mini classes. Like it was just like you did 7 or 8 different things. Yeah, so that's gonna be my my Math for Game Programmer stream number 1. I've apologized repeatedly. I'm gonna apologize again. The quality is a little bit all over the place because I'm teaching myself not too far ahead of when I'm teaching you guys. And the reason I'm making this, the reason I'm not just saying, okay, well, this information exists, go out there and find it, is pretty straightforward. That most of the information that does exist is not presented in an accessible way. It's kind of frustrating that way. And so I'm trying to start kind of from zero, and I'm trying to apply the principles as soon as possible. So we're not ever going to be learning something and then be like, okay, why do I need this? Why do you need this? Well, do you want your character to be able to move in 3D? I hope so, because we're making a 3D game. And you can apply this to 2D as well, to some degree. Most 2D games don't do this, but I'm sure there's some that do. Okay. Yeah, I'm tired. I do want to do another stream. Ideally, yeah, I think that might be today's stream. I'll see if I can do more later, but that's it for right now. Thanks everyone who came. Thanks everyone who is watching the VOD. If you're still here and you're not subscribed yet, I would very much appreciate it if you subscribed. If you haven't liked the video already, please do that. And more coming from this series in the future. And not just more streams, but more. I haven't decided yet if I'm going to edit this stream down or if I'm just going to start over. But either way, a nicer version of this video will be coming out soon, and then we'll go from there. And I hope it'll be useful to you. And I'll probably, I hate shelving projects, but what I'll probably do is I will shelve this project, make a more, well, I mean, this project is pretty simple. No, I want to finish this project, but I'm probably going to also make some sort of basic example projects. I'm going to make some other basic example projects to illustrate the points I'm making and how you can immediately use them, because I think that sort of snappiness is, you know, here's a thing, here's how to use it, go nuts, is very important to the way I learn. The way I learned, I really don't like to be told, okay, well, you'll need this later, so just be patient. No, I want to use it now. I'm very impatient. And in some ways that's a strength, in other ways it's a weakness, but that's just how I am. And I am a firm believer in trying as much as you possibly can to not waste the student's time. Thank you, C0. And the way that I know to do that is just say, here's the concept, here's the application, go for it. Actually, no, we're going to go on a quick tangent here. So there's something I've seen described a lot as let's see, maybe on the right layer. So quick tangent. This actually tangent. That's some vocabulary here. We got our unit circle. Here's this point. Here's a line that goes through the point but only touches the circle at one angle. Basically, if we have our right triangle, we can sort of you can make your right triangle this way in addition to making it this way. Anyway, quick tangent. So I've heard a lot of people discuss tutorial hell. And what I think this basically is you have a tutorial and you say, okay, well, this is a cool farming game. Let's make this farming game. And so you start at the start of the video, go to the end of the video, and you say, okay, and you've got this game, but you're not happy with it. But you didn't actually learn enough to make a better game. And the solution to this basically is don't rely on any one tutorial. Watch a bunch. Watch a bunch of different tutorials to different lengths, and just as soon as you disagree with the author, be like, no, go away. This tutorial is actually pretty good. I'm going to watch it all the way here. But actually, I only need this much. I only need like 80% of the video for what I want to do. And this one, oh, this one's garbage. Let's just not even bother. Right. So that's tutorial hell. That's how you solve it in 60 seconds. Note to self: make a clip of that. And that's sort of an extension of this immediately teach the application strategy, because a lot of it is like, okay, we want to make a stack of 6 boxes. So step 1 is stack this box. Step 2 is stack this box. But people who want to stack boxes, generally they want sort of a general, right, box stacking. They want a general box stacking algorithm, right? Stacking, whatever. And so if you watch 6 different tutorials on how to stack boxes, you'll probably figure it out. Or if you watch one really good video, but the really good video is probably like, here's how to stack, here's how to stack bicycles. Right, if you want to stack more than one bicycle, these are not good bicycles, don't worry about it. But then, if you want to stack bicycles, well, let's start with a simpler shape, like a rectangular prism. Guess what a rectangular prism is? That's fancy words for box. That's been my experience with tutorials. It's very, very unlikely that you will encounter the tutorial that just solves your problem. You need to be able to take some percentage of the information that you find in the tutorial, add your own brain. Here's a brain, right? Add your own brain equals the actual thing you want. Here's the shiny, nice thing you want. And right, you can't ever use 100%. You gotta use some percentage that's less than 100%. Okay, there we go. I'm gonna call that a stream. Thank you so much, everyone who came. Please remember to clip this, because I think this is gonna be a good clip. And honestly, if I'm clipping just that section, I should probably just edit the whole video. See if I can get anything out of it. Fill the gaps with some post-recorded content or something. Yeah. Have a lovely rest of your day, everybody. I hope to see you all around.